All right, so today we're going to go over the AP Calc free response. This is AB from 2016. And I'm going to focus on the non-calculator questions since those are primarily what you're meant to be getting. All right, apparently this exam can be done without a calculator. So we're going to focus on those. All right, so the graph shown above shows a piecewise linear function f, and then g is defined as the integral of f. So we can think of f as the first derivative of g. All right, does g have a relative minimum, relative maximum, or neither at x equals 10? Okay, so how do I go about approaching this? So I would notice that f of, I guess it's t. So f of t here is equal to 0. So this is a critical point of the function. All right, and so the critical point is where the derivative of a function is equal to 0. All right, and that could be a minimum, a maximum, or neither. All right, and so just by way of review here, if I have f prime of t, all right, and this is my, I'll just call it a point C here. If I go from positive to negative, then this would be a local max. All right, if I have a point C and I go from negative to positive, all right, this would become a local min. All right, but in this case, what we have is a situation where we go negative to negative. So this is neither a min nor a max. Does that make sense to everyone? So that is neither. Everybody okay? Yes, no? So for those of you who haven't joined us before, you can answer yes or no by just typing okay in the chat box, which is here. This will give me an idea if everybody's okay. Fantastic. Okay, great. All right, does the graph of G have a point of inflection at x equals 4? Okay, so let's take a look at that question. So if I look at the derivative, okay, let's see, there is a question. Is the reason because it isn't 0? No, it is 0 actually. So it does reach 0. The reason is that the reason is that it is both, the derivative here is negative and negative. So I don't have a change in the sign of the derivative. So you can write that there's no change in sign. So therefore it couldn't be a local min or a max. Okay, so then for B, we want to know if we have a point of inflection. So a point of inflection is a point where the second derivative is equal to 0 and there's a change in sign of the second derivative. All right, and so if I look at f double prime here, I would be taking the derivative of the derivative. All right, so I'd be taking the slope of the line that's right here, so from 2 to 4. So from 2 to 4, the slope is positive, all right, and then from 4 on, that slope is negative. Okay, so therefore, this is an inflection point. Okay, so we can say that G has an inflection point at t is equal to 4 because your second derivative goes from positive to negative. Okay, and then just by way of review, when that second derivative is positive, we know that the graph is concave up. All right, and when it's negative, we know it's concave down. So what's going on here, I'll try to draw this well. All right, what's going on is we have something like this, all right, where we go from the graph is facing up, concave up, to the graph is facing down, concave down. Okay. So do we state that the graph is differentiable and continuous? You do not need to state that for this question. So differentiable implies continuous. Okay, and does up mean positive? No, up means concave up means literally it's facing up. Not necessarily. So let me see if I make sure I answer your question correctly. So when the second derivative is positive, the graph is concave up. I could have easily drawn the graph down here though. All right, and this would have still been concave up, even though the graph itself is negative. Good questions. Yeah, no problem. All right, find the absolute minimum and the absolute maximum on the interval. Okay, so what we want to do is first you want to think about what your possibilities could be here. All right, so what I would tend to think about is you want to consider the endpoints. All right, you always want to consider the endpoints when you have endpoints. All right, so you want to consider the endpoints, and then you want to consider points where f prime is going to be equal to 0. All right, but let me be more specific, and changes sign. Okay, so those are the only points that we really have to consider. All right, and so it only changes sign at -2 and then again at 6. All right, does anybody have any questions on that part? All right, so we have to basically make a little table with just those points. All right, so we have to consider the endpoints and we have to consider where the derivative changes sign. Okay, so x, and then we're going to have to find g of x, unfortunately. All right, so we have to find -4, -2, 6, and then 12. Okay, so let's see. Okay. Why those specific points? So this is an endpoint. This is an endpoint. And then this is where your derivative is equal to 0 and changes sign. All right, and that's the only place that you could have a local max and min. All right, and there's could be absolute maxes or mins, or it could not be. Okay, so I would start at 2, I think. All right, no problem. So then we know that the integral from 2 to 2 of f of t is going to be 0. All right, so I have an initial value that I can work with. All right, I know that 2, 0 works. Does that make sense? Because I'm defining my function that way. Yeah. Okay. All right, so then we should figure out the area that is under our graph to get in different directions. Okay, so let's consider the triangle from 2 to 6. All right, so the integral from 2 to 6 of f of t is going to be 1/2 of the base, which is 4, and the height, which is 4. All right, so 8. And then since I'm starting at 0, this is 8. All right, and then similarly, this would be -8. All right, and then I have to get the area for moving forward. All right, so if I wanted to find g of 10, for example, all right, I would take my 8 and then I would add the integral from 6 to 10. All right, this is the function defined at 6. All right, so I'm essentially taking my initial value. All right, and then this becomes 8 plus 1/2. My base is 4, and then my height, I'm going to call it -4. All right, so I'm back to the point at 0 at this point. All right, and then to get to 12, I would do 1/2, the base is 2, and then the height is -4. So I would get -4 for that one. All right, and then if I do the same thing over here, I end up getting -4. All right, so, all right, it looks like then that this is your absolute min, and then this one is your absolute max. All right, and then we just want to make sure that we're careful here. When they say absolute min and absolute max, you want to make sure that you report the y values. All right, if you give the x values, you'll get it wrong. All right, does that make sense to everybody? Yes? All right, great. All right, for -4 to 12, find all of the intervals for which g of x is less than 0. Okay, so I think we found part of it. So everybody agree that we're going to be less than 0 from -4 to 2? All right, and then from there, I was positive, so I was 0 at this point, right? All right, and then I got up here to positive 8, and then I got back to 0 here, and then I added some negative area. So then this is 10 to 12. All right, so I think that that would be the answer there. Does anybody have any questions? Okay, so let me answer the question. Why is it negative from -4 to 2? Okay, so if I'm at 0 here and then I have positive area, but I'm going this way, then it becomes negative area. All right, so I'm gonna like go forward with the next question, assuming that slope fields are going to be tested. All right, even if you don't have to draw them, I think it's good to practice. Okay. All right, so on the axes provided, we want to sketch a slope field for the differential equation. How much faster than this pace will we have to go? So you get, you have 2 questions to do in 45 minutes. So that would be on average 22 minutes. And we just spent less than 20 minutes on that. So we're on pace. Okay, so to make a slope field, all you do is take the point and you plug it into your equation for dy dx. All right, and so then you get a slope and then you plot it. All right, so when we have 0, 0, this becomes 0 over 0 minus 1, which is 0. So a slope of 0, I'm going to draw it in a different color so you can see, looks like that. All right, and then if I look at the point 0, 1, this is 1 over 0 minus 1, which is negative 1. All right, so I get a slope like that. For the point 0, 2, you would get 4 over 0 minus 1, which is negative 4. So a much steeper negative slope. All right, and then 2, 0, I should get 0. For 2, 1, I would get 4 over, let's see, 1 over, let's see, goodness, 2 minus 1, negative, positive, hold on. What did I do? Hang on. Okay. 1 over 2 minus 1 is 1. There we go. It's always the arithmetic that gets me. 2, 2. Uh, 4 over, yeah, okay. Something like that. All right, everybody okay with how to construct the slope field? Not too terrible. You just plug them in. All right, great. Okay, so let y equals f of x be the particular solution to the differential equation with the initial condition. Write an equation for the line tangent to the graph at x equals 2, and then use your equation to approximate. So we now have the point 2, 3. All right, we can get the slope by plugging this into the differential equation. So the slope would be 9 over 2 minus 1, which is 9. All right, and then to make the tangent line, y minus y1 is equal to mx minus x1. All right, where this is the point x1, y1. So y minus 3 is equal to 9, x minus 2. All right, now we could just leave it, and probably smart to leave it. Let's actually leave it. Let's just move the 3 over. All right, so there's my tangent line. And then if I want to figure out f of 2.1, then I'm plugging that in for x. So f of 2.1 is equal to 9 times 2.1 minus 2 plus 3. All right, so 9 times 0.1 plus 3, which should give me 3.9. All right, does anybody have any questions on part 2? Awesome. All right. Okay, find the particular solution when, oh no. All right, find the particular solution to the differential equation. So to do this, we're going to have to separate variables and solve. All right, so I'm going to start with dy dx is equal to y squared over x minus 1. I'm going to get all the y's on one side and all the x's on the other side. So you have dy over y squared is equal to 1 over x minus 1 dx. All right, and then from there you want to integrate both sides. All right, when you do that, this side becomes negative 1 over y is equal to ln absolute value x minus 1 plus c. Okay, and then usually from here, you can either solve for y, or I plug in the initial value at this point. That way it doesn't give me any time to make any arithmetic errors. I have a habit of making arithmetic errors, so I try not to do that. All right, so I'm going to plug in my initial condition at this point to solve for c. All right, so then my initial condition, y is 3, so negative 1/3 is equal to ln of 2 minus 1 plus c. All right, this becomes ln of 1, which is 0. So I know that c is equal to negative 1/3. All right, and then I can plug that in. All right, and then to solve for y, you would multiply it and then divide by this whole thing. All right, so y becomes, let's see, so negative 1 over ln x minus 1 minus a third. And then if you want to clean that up for whatever reason, this is equivalent as 1 over 1/3 minus ln x minus 1. Where did I get the formula with the ln? So the integral of du over u is equal to ln of u plus c. All right, and then in our particular situation, u is equal to x minus 1. So it becomes ln of x minus 1. Okay, any other questions? Why is c 1/3? So that's where the initial value comes in. You plug in x, y as 2 and 3 from the problem. And then you can solve for c. No problem. Okay, any other questions? All right, moving on. All right, so inside of a funnel of height 10 inches has circular cross sections, and at height h, the radius is given by this thing. And then we want to find the average value of the radius of the funnel. Okay, so, all right, so let's remember the formula for the average value of a function. All right, the average value is equal to 1 over b minus a, the integral from a to b of f of x dx, right? So in this case, b and a are your bounds, which are 0 and 10, and then we have a function. So we're essentially just going to plug in and solve. So your average value is 1 over 10 minus 0, the integral from 0 to 10 of 1/20th, and then 3 plus h squared, and then dh. All right, so I can pull out that 1/20th and get 1 over 200, the integral from 0 to 10 of 3 plus h squared, dh. All right, so 1 over 200, 3h plus 1/3 h cubed from, and then we're going to evaluate that between 0 and 10. All right, so 1/200th. All right, 3h is 30 plus 1/3 of 1,000. And when we calculate, we get 109 over 60 inches. Right, and apparently this is something that we should be able to get without a calculator. But you guys will have one available to you if you need it. All right, so that's average value. For the volume, volume is equal to pi, and then remember that you're going to take your function and then the integral squared. All right, so your volume is equal to pi 0 to 10. So I pulled this out, and then 1/20th times 1/10 is 1 over 200. Okay, so 1/20th, and then 3 plus h squared, and then we're going to take this whole thing and square it. All right, so basically pi r squared. All right, so I can kind of clean this up a little bit. Pi over 400, I'm going to pull that 1/20th squared out. All right, and then this becomes 9 plus 6h squared plus h to the 4th. All right, dh, that's just foiling this thing. All right, and then I can integrate. Okay, so we got 9h plus 2h cubed plus 1/5 h to the 5th. All right, and then I'm evaluating from 0 to 10. All right, and so pi over 400. All right, and then, so remember on this AP exam, you don't have to simplify. I would probably just not simplify it. All right, but 90 plus 2 times 10 cubed plus 1/5, 10 to the 5th. All right, and I would personally just leave it like that. All right, you don't have to simplify it. So don't get yourselves in trouble. All right, anybody have any questions on that question? Great. Okay, the funnel contains liquid that is draining from the bottom. What formula is used for the volume? Volume is equal to pi, the integral from a to b of your function squared, and then dt. All right, at the instant when the height of the liquid is 3 inches, the radius is decreasing at a rate of 1/5 inch per second. Okay, so, all right, so let's figure out what we're given. So we're given an h, and then they tell us that the radius of the surface is decreasing at a rate of 1/5 inch per second. All right, so this is a related rate. So this is dr dt that they gave us, and it was negative 1/5. All right, and then I can keep the units in if I want them, inch per second. All right, and then we can use your formula to find your relationship between r and h. All right, so if r is equal to 1/20th and then 3 plus h squared, if I differentiate both sides with respect to t, then I get dr dt is equal to 1/20th, and then I want to take the derivative of this thing with respect to t, and I would get 2h, but then I can't forget the chain rule, dh dt. All right, so that's that. And then we're asked to find the rate of change of the height of the liquid, so we're asked to solve for dh dt. So we can now plug in what we're given. So negative 1/5 is equal to 1/20th, and then 2 times 3, and then dh dt. All right, and so then we're left with, let me erase this. All right, we're left with negative 1/5 is equal to 6/20 dh dt. dh dt is then negative 1/5 times 20 over 6. All right, and so then I should get negative 4/6, which is negative 2/3. And then units would be inches per second. Okay, does anybody have any questions on that question? All right. Okay, and then the always fun table questions. All right, so we want to be real careful with the details here. All right, so we have functions f and g, and they tell us that they have continuous second derivatives. That's good. All right, so if k is equal to f times f of g of x, so this is function composition, write an equation for the tangent line to the graph. Okay, so what we want to do, we have to figure out our point, all right, and then our point here is going to be 3 and then k of 3. All right, and then we have to figure out what k of 3 is, which is f of g of 3. All right, so then we can use our table to figure out what g of 3 is. That's 6. So this is f of 6, which is 4. So our point is then 3, 4. Okay, then we need to figure out what k prime of 3 is. But I'm going to start with k prime of x. All right, so k prime of x, so we have to use the chain rule. This is f prime of g of x times g prime of x. All right, and then I can kind of plug in from here, f prime of g of 3 times g prime of 3. All right, g of 3 is again 6, so f prime of 6 times g prime of 3. All right, f prime of 6 is 5. And then g prime of 3 is 2. So this is 10. All right, so k prime of 3 is 10. So then we put it together in a tangent line. Y minus y1 is mx minus x1. So y minus 4 is equal to 10 times x minus 3. All right, and you can leave it in that form. All right, so pretty big chain rule question there. Does anybody have any questions? Why is it y minus 4? So your point becomes 3, 4. And we figured that out by using the composition of the function. No worries. Okay, so, all right, so here, how did you know what to use to find the slope? So the slope is always the derivative. All right, and I had to use the chain rule because my function was defined as a composition. Okay, so h of x is now defined as a quotient. So we have to use the quotient rule to find the derivative. All right, so h prime is so low d high minus high and then d low over low squared. All right, that's the quotient rule. And then we can plug in from there. So h prime of 1 is then f of 1, which is -6, g prime of 1, which is 8, minus g of 1, which is 2, f prime of 1, which is 3, and then I'm dividing by -6 squared. Right, and then again, you can leave it like that this year, totally fine. Okay, any questions on part B? All right, great. Okay, so C is a little tricky, all right? So in order to take the integral of this, I have to remember to that this is kind of like a u substitution here. All right, so if I let u equal 2x, all right, then du would be 2 dx. All right, but I don't really have an entire du. All right, so I would have to correct my integral here. All right, and to do that, I'm gonna put in the 2 that I need. All right, but then to correct for putting in a 2, I can't just multiply an equation by 2. I have to multiply by 1/2. All right, and so then when I multiply by 2 and 1/2, it's the same as multiplying by 1. All right, so then I can integrate this now. All right, this becomes 1/2. All right, the integral of a second derivative is just the first derivative. All right, from 1 to 3. All right, using my bounds. So then I have 1/2, and then f prime of plug in the 3, I get 6. And then plug in the 1, I get 2. Right, and then so I get 1/2, f prime of 6 is 5, and then f prime of 2 is -2. All right, and then together I get 7/2. All right, so that was a little tricky. You had to remember to correct your integral. Does anybody have any questions? So the endpoints didn't change from 1 and 3, but when I plug them in to my function here, I get 2 times 3 is 6, and then 2 times 1 is 2. So they didn't change. I just plugged them in and got the entire thing. So I don't know how you learn this, but when I learn this and when I teach it, whenever I'm doing a correction, because I have the u substitution, you have to, when you do the substitution, you have to substitute the u and the du. And if I look at this, du is 2 dx. I don't have 2 dx here. So I have to put in the 2, but then by putting in the 2, I'm just multiplying by 2. I can't do that. I have to multiply by the half. All right, and then it's essentially multiplying by 1, and then I can do the substitution. All right, then this becomes the integral from 1 to 3 of f double prime of u du. All right, and that's just f prime of u. And then you plug this back in.